OQ. Ah, I'm seeing some stuff here. What else are they saying? An angle POQ is 40 degrees. Okay. They said use pi as 22 over 7. When I see questions like this, yes, I know it's a measurement related. It could also include some geometry formulae and stuff too. So it says determine the value of angle OPQ. So we find the angle P, right? The letter in the middle. It said OPQ, which is this angle here. Come on, did anybody get that answer? Anybody? If you did, what did you get for it? Quick, quick, quick. We don't have all
70
nine
degrees.
70 degrees.
Yeah.
Okay, that is correct because the fact that they said, right? OP, where was it? OP, which is this side, is equal to OQ. It means it's an isosceles triangle. So since we know here's 40 and this is these two sides are equal, it means the opposite angles from the side. So this angle here is equal in size to that angle over there. I know I have a lot of thing on the screen. I'll just take off this, right? So these two angles, they are the equal angles. So all we have to do is say 180, take away 40, which will give us 140, right? And then the two remaining angles, which are the equal angles in an isosceles triangle, you divide this by 2. 14 divided by 2 is 7. 0 divided by 2 is 0. So 70 degrees. Both of them will be 70 degrees. We could put it in case we need it. But the actual answer here would have been 70 degrees. You'll see why they give 1 mark, right? Yeah. Even though they should have given a little bit more. Moving on to the next part. It says here, calculate the length of OR. OR, where's O and R? Oh, from O to R. I see. Okay. So what I would do, I would focus on the rectangle, at least for now, because OR is a side on the rectangle itself, right? They also said that O is the midpoint. When it says midpoint, it means O divides SR, which could also be known as RS, in half. Okay, so if it is, we knew, let's say, the length of this side, we can figure that out really easy. So let's see, they give us the length of this side. I know that opposite sides in a rectangle are equal, so these two sides will be equal. Um, but this piece here though. Okay, if you look at this, right, this is a triangle by itself too, because apparently the rectangle doesn't have enough information. So then I need to look at another shape, right? So I'm looking now at hold on. That's the thing with these questions, right? That's why the more shapes you'll know, easier it'll be, right? So I'm just doing a sketch here. We have Q, we have R, we have O, we have 14. Oh my, I think I ran out of space there. Yes. 14.1 is supposed to be, So 14.1. We need to find this side. This is 90 degrees. Now you're already, how does 90 degrees? All rectangles, squares, most quadrilateral, regular ones, all their vertices are 90 degrees, right? So that's about knowing the properties of rectangles and stuff. So because this triangle is within the rectangle, this angle here is 90 degrees. Okay, now if we want to use like we can either use Pythagoras theorem, but to use Pythagoras theorem, oh, we can use Pythagoras theorem. We need to know two sides. And if you look real close, right? And they told us just now that OP is equal to OQ. OP is here, 15. OQ is here. So these two sides are equal, and we know why, because it's an isosceles triangle, right? So that means this side here is 15. So we do know the hypotenuse, right? So yes, we could definitely use Pythagoras theorem because Pythagoras theorem is used in any 90-degree triangle to find a missing side when you're given the length of the other two sides. So yeah, c squared is equal to a squared plus b squared. We already know c squared. C is always the hypotenuse, so we know the hypotenuse. The hypotenuse is the longest side of a right angle triangle, and another way to identify it is always opposite or straight across from the 90 degrees. Right? So we know C. The other two sides, anyone will be A, anyone will be B, right? So I could put here as A, I could put here as B, and the reason why you can label any of the other two sides as A, B, because we have to add them at some point. I think you'll know that by now. And when you add in, addition is commutative. So it doesn't matter which number you put first when you're adding, you get the same thing. So since we know A, B, and C, or we label them, we can replace the numbers. So C is 15 squared, A is 1. Well, that's the side we're trying to find, right? Which is OR. Or we could have left it as A squared too, we didn't have to change it, but leave it. So either or, it'll be fine. B is 14.1. I run out of space again, boy. I run out of space here. So that's supposed to be squared, right? 14.1 squared. Calculator, I need your help. So 15 squared is what? 225. We could put back OR, or if you want to leave it as A squared, plus 14.1 squared. 14.1 to the power 2. Okay, I got one. Sorry. I got 198. 198. Oh boy. 0.81. I realize I write it too close to the edge. And this is not the normal annotator that is used, so I can't write over across from here. So when do you SOHCAHTOA? Okay, I'll tell you just now, right? Um, I'll tell you just now. Let me just finish this up quick. So we could transpose for this stuff here, right? Get OR by itself. We need to move this. First, it's adding, right? So we could take it away. We could write over the whole thing like how others do it. If you want, just take it away. Just make sure you have some working to show, right? Because how much mark they're giving out? 2 marks here. So sometimes you have to give CXC what they're looking for because 2 marks, just make sure you have enough working, right? You don't have to overdo the working. So if we take away this on both sides, it becomes 0, leaving us with OR squared here. And when we take away that, 225, take away 198, oh my, 198.81. Excuse me. I got there 26.19. And because we have a power here, we need to find the square root to get rid of that power. Find the square root on both sides so the equation remain equal and balanced. So this will become OR is equal to, what's the square root of 26? Sorry, 26.19. Okay, I got 5.1. If I write it to one decimal place, why am I writing with that? Yeah, it's 5.1. Okay, is it meters? Yeah, meters. Okay, okay, okay. Yeah, so that should be correct. Yes, that has to be correct. All right, so based on what you asked, right? To use SOHCAHTOA, right? Sine theta, cos theta, tan theta. It must be using a right angle triangle. So the triangle must have a 90 degrees. So just like how If I didn't know the length of two sides in this triangle, I would have ended up using SOHCAHTOA. But in order to use SOHCAHTOA, one of them, of course, the triangle has to be 90 degrees, just like how we have the 14.1. And seeing that we needed to find OR, I needed to know one other angle in the triangle other than the 90 degrees. So if I knew this angle, let's say this angle is 30 degrees or something, I could use SOHCAHTOA. I could use SOHCAHTOA, but then I have to decide which SOHCAHTOA. So in other words, if I need to find this side here, normally first and foremost, I will label the hypotenuse, right? Right, the hypotenuse. I am back again. I don't know why tonight I'm getting these disruptions. Come on, don't do me this. Okay, so what I was saying, right? I will label the hypotenuse, and then since I need to find OR, if I had another angle, this other angle will be theta. You cannot label the 90 degrees as theta, never. You need another angle to label as theta. And then from that angle, you go across here. You can ask, okay, well, this side is opposite or straight across from 30 degrees, so it will be the opposite side. So from theta is where you identify your opposite side, and the other side next to theta is adjacent. So then to decide whether it's sine theta, cos theta, or tan theta, how do I decide? Well, what side do I need to find? Well, based on what I have labeled there, the side OR is the opposite. So the formula must have opposite, and the only two that has opposite is sine theta and tangent. But in addition to that, it has to be one of them. It can't be both of them. It can't be sine and tangent. So which one really should we use? So then I will ask myself, because I also need to know the length of a side to use a SOHCAHTOA formula. So since I need to find the opposite, and the only other side I know the length of, in this case right now, based on how I left out the 15, is the adjacent side, I would use tan, because tan has opposite and adjacent. So that's one way, but there are other things you really want to look for. So if it is, or probably I'll see what I could do. I can't remember what questions it have in this paper, right? Um, but when I check if it have any questions below that requires me to use one of those trigonometric ratios, so I will give you a little more briefing on it. So this is just one scenario, right? To figure out which of them to use. But the triangle must be 90 degrees for sure. All right, and you could use SOHCAHTOA to find either a missing side or a missing angle. Okay, so we just found that the length of OR is 5.1 meters, okay? All right, moving on. What else we need here? So let's calculate the area of the shaded portion of the diagram. Shaded portion. So that's the triangular part and the semicircle. Hmm. Let me just clear some of these things here because it just looks messy. Just don't like how it looks messy, but um the triangle. In order to find the area of this triangle, let me use this sketch diagram, right? There's a formula. There are at least three areas of a triangle formula, but the two that normally comes the most, that you have to use the most, is the base by height divided by 2, but you could only use that if the triangle has a very define height. It must have a height. This triangle has no height. If it had a height, it would have a line here, perpendicular with a 90 degrees, and it would have told you what the length or height is. Doesn't have no height. So then the other formula to use for area when you don't have a height in a triangle is the one where you are given the length of two sides. So we know the two equal sides are 15 um meters. Why put centimeters here? And the angle between the two sides, which is the 40 degrees. So area of a triangle, when given two sides and the angle between them, is half the product of AB by sine theta, sine of the angle. Let me just move this from the way for now. Okay. This formula, if you don't know it, is actually on the past paper, right? It would have been good if you did know it by heart, but if you don't know it by heart, it's one of the few formulae you get on the past paper in the formulae list. So it's there. Um, so A and B, it don't matter which side you label as A and B. And like I've said with addition, when you multiply it, um, it don't matter which number you put first. And we have 15 and 15 anyway, so yeah. And theta is the angle between the two sides. So it will be a half multiplied by 15 again by excuse sine of theta. Theta is 40 degrees. So we could put that in the calculator. Let's see here. I have 1 divided by 2 multiplied by 15 multiplied by 15 multiply. Make sure your calculator is on degrees when we're using sine and cos and tan. Uh, yeah, so that is sine of 40. I got there. I write my answer to probably 1 decimal place. Okay, so it's going to be the 1 is less than 5, so it will be 72.3. We found area, so this is meters squared. But that's not the full answer there. What they said, they wanted the area of the shaded portion. We only found part of the shaded portion, which was the triangle. We still need to find the area of the semicircle. Now, there's no specific formula to find the area of a semicircle. Wait, hold on. But what we could do, we could find half of the area of the circle. So normally to find the area of a circle, right? So area of a circle, I think that's also in the past paper too. Because it mainly have like some measurement formula they have on the past paper. So area of a circle, if you were finding the area of the full circle is pi r squared. But we're finding the area of a semicircle. They said it's a semicircle, right? So that's half of a circle. So what we'll do, you can either find the area of the circle and then multiply by half or divide by 2, or just insert a half in the formula and you get it either ways. So they said use pi as 22 over 7. What is the radius though? Ah, we need the radius. We need the radius. They didn't give us, if they give us this length, this would have been the diameter. Because half of the circle will have the diameter. And then we could have divided by half and get the radius. But I'm not seeing, um, let me see. What did I find before? OR. Ah, that was the key. You see? So sometimes your previous answer was supposed to help you. You remember when we had to find OR, which is from O here to R, and I got 5.1. Okay, so if OR is the midpoint, which divides RS in half, that means from O to S is also going to be the same 5.1. So this entire line, 5.1 at 5.1 is 10.2, right? But we don't need 10.2, but just saying. So that means PQ is also going to be 10.2 meters. Why? Because it's a rectangle. We look at a rectangle, and opposite sides in a rectangle are equal and parallel. So that means PQ is the diameter of the semicircle. So PQ is the length of one side of the rectangle, but it's also the diameter of the semicircle. In order to find a radius, you divide diameter by half. But we don't have to go back and divide diameter by half because we already know that half of the line is 5.1. So the same thing going here. Half of this line, which will give us a radius here and another radius here. The radius is 5.1. I hope you understand that, right? If not, let me know. If it's confusing, let me know. Okay? If you're clear, well, that's good. If you're unclear, if you're lost, if you're confused, tell me and I'll just probably do a separate sketch and explain it over. Excuse me. You understand? Okay, great. Okay, so I am going to 1 divided by 2 multiply by 22 divided by 7 multiply by 5.1 squared, which is the radius squared, gives us what? Uh, okay. So I got there. I think I'll write it to one decimal place, which means 7 is 5 or greater than 5. So we have to add 1 to the 8. What is going on? But what trouble is this? What is this? What is this? Just so, yeah. Where did I? Anyhow, it would have been 40.9, right? Can I see the history of this thing? Your calculator up here. It is 40.9 on the screen if you remember. Did anybody see what I have on the screen just now? I was calculating some weird stuff for me this hour of the night. There was 40 point some 8, and then I said 7 is 5 or greater, so you have to add 1. So it's 40.9 meters squared. So the final thing to do to find the area of the shaded portion. The shaded portion again consists of a triangle and a semicircle, so we will add their areas. The area of the triangle is 72.3. What is going on? 72.3. And the area of the circle is 40.9. Okay, so when we add those two, when we add those two areas, let us see, 72.3 and 40. Whoa. Really? Really, really, really? Okay, 70.3 and 40.9 is a total of, say, wants to give me trouble for no good reason, man. 113.2 meters squared. So that's the area of the shaded portion. Good night, Abigail. Welcome to you. We're doing a measurement question from the past paper I sent last week. All right. So if anybody have questions, you know what to do, right? The next part says find the area of the cross section PMQROS. Is that a full diagram? PMQR. Yeah. So it's a full diagram. They want us to find the area of. Yes, good evening to you. Let's see here. I don't know about you, but this was last year, May, June, and I find me personally I find this was probably one of the easiest paper tools I saw in a minute. So I hope you all get something decent tomorrow. Okay. I find it was easy. I mean, I mean, I've been around maths for a while. So I have an idea if the paper is easy or kind of tricky or what. Um, so they want the area of, not the area, the perimeter now, right, of the entire diagram. So that means we know here's 14.1. I remember, like I said before, opposite sides, right, in a rectangle are equal. So this side is also 14.1. We know just now we found that OR is 5.1, right? So we could either put it back as 5.1 here, and we also know that this side is 5.1 because OR is the middle. And this entire thing is 10.2 because opposite sides. But we don't need that actually because when you find in the perimeter, you find the distance around, so we don't even need to put that there, right? You just need to know the sides around the diagram. So we have almost all the sides except the arc. So we need to figure the length of this arc and then add it to this and that and that and that, and we get the perimeter. So length of the arc, I'll find it on here. LOA, length of an arc is equal to this formula as well is on the past paper. So if you all don't know it, you get away. But when I say get away, I mean you could check the formula list, okay? But some of those formulae are not there, so let's see about this. So length of arc is theta over 360 multiplied by the circumference of a circle, which is 2r pi or 2 pi r. So theta, oh, let's see here. What's theta for this now? Well, if this is a semicircle, right? The angle that this represents is 180, remember? An entire circle has a total of 360 degrees. So if we have a semicircle, it will have half of 360, which is 180 degrees. So theta will be 180 degrees divided by 360 multiplied by 2. We know the radius that we talked about just now. The same radius is going to be 5.1. And they told us to use pi as 22 over 7 here. So we're using pi again as 22 over 7. And listen, don't you all make sure work with your calculator scientific to be precise. You don't want to work with no um basic calculator because you won't be able to calculate your trigonometry with a basic calculator. So 180 divided by, do not leave your calculators home at all. Nobody wants headache in their exams. So, because then if you leave your calculator home, you have to work out this manually, and that's going to take up time. And like I said, you can't work out trigonometry without a calculator at all. You might be able to do some of the working, but not most of it. What did I get there? 3 points. Just double checking. 180 divided by 360 multiplied by 2. Oh, okay. But math has done it to me. In this, I need to put these things in brackets because but math gave me a bad week here. I knew it was off when I saw what I saw just now. So I'm putting the fractions in brackets because all these multiplication sign and stuff like that giving me a bad job. Okay, so then we multiply in by, or I probably also left out something, but so avoid whatever happened just now there. Put the fractions in brackets. Okay, that's more like the answer we need here. So the length of the arc is 16. I think I write that to the nearest whole number. Yes, 16 meters, right? The other sides were in meters, so the length of the arc is in meters. But they didn't ask us for the length of the arc, they asked us for the perimeter. So since we know the length of the arc is 16, okay, 16 meters, now we can proceed to add all the sides. So the arc, which is from here to there, because perimeter means you add all the sides, then you add in this here, you add in these down here, and add in that, and you will get the perimeter. So it's 16 at 14.1 twice and 5.1 twice. Okay, so 16 at 4.1, not 4.1, 14.1 at 14.1 again at 5.1 twice will give us the perimeter. Okay, so 16 and 14. What? 14.1 and 14.1 and 5.1 and 5.1 again. Okay, what do we get? 54.4, yeah. 54.4 meters, because all the sides were in meters. Perimeter, you need no square or anything else. So that's the answer there. You all, if you have questions, let me know. If anybody have any questions, if anybody